Hello everyone. So now we are going to solve this question number 2 of paper 4 2025 February March. So the first question talks about ionic compounds. This question is about ionic compounds. State what is meant by the term ionic bond. So we have ionic bond, covalent bond, metallic bond. They're asking about ionic bond. So ionic bond is the bond that is formed because of the electrostatic force of attraction between oppositely charged ions. Now let's understand few terms here. What are ions? Ions are charged particles. Ions are charged particles that have charge. For example, Na plus, Cl minus, Mg2 plus, Al3 plus, SO4 2 minus. They are all called ions because they have charges on them. Now, what is this electrostatic force? So, dear children, electrostatic force is nothing but the force of attraction that exists between charged particles. Electrostatic force. It is the force that exists between charged particles. Now, charged particles can be of similar charge, for example, Cl minus and SO4 2 minus, or they can be of opposite charges like Na plus and Cl minus. So it can be of attraction and as well as repulsion, anything. But it is the force that exists between the charged particles. So how you will get 2 marks for this question is one by stating that it is electrostatic force of attraction, and the second by stating that it's between oppositely charged ions. This whole will give you 2 marks in total. So 1 mark for this, 1 mark for that. The second part of the question says potassium sulfide is an ionic compound. Complete the dot and cross diagram for this of the ions in potassium sulfide. So if we talk about the electronic configuration of potassium, it's 2881. That's the actual configuration of potassium. But here they have shown just 2 shells, 2 and 8. That is being shown to us. Now we have to decide that how many more shells shall we show here for potassium. Now, dear children, for that we should know that potassium bears a +1 charge because it loses 1 electron to have 8 in its outermost shell. So it loses this electron of its. So we are supposed to draw just one more shell. Let's draw it. And that shell will have how many electrons? 8. So 1, 2, 3, 4, 5, 6, 7, 8. And what charge should come here? It should come positive, +1. So now we have drawn 2, 8, 8, which shows the configuration of K plus ion. This was for potassium. Same will happen with this potassium. Potassium can have just +1 charge. So we'll have to show 1, 2, 3, 4, 5, 6, 7, 8 electrons here. So this is 288. That's stable. Again, a plus charge. Let's talk about sulfur. So sulfur's configuration is 2, 8, 6, right? 286. So it has 6 valence electrons. And so it needs 2 more electrons to be stable. If it wants this to become 8, it needs 2 more electrons. So what's going to happen is this should have 3 shells and the third shell should have 2 more electrons. So let's see. We'll draw one more shell, and because sulfur's electrons are shown with cross, we'll draw it with cross. So how many crosses? 6, because 6 are already present. 6. but we'll add two more electrons, one from this potassium and one from this potassium. One electron has been lost by this potassium, one electron has been lost by this potassium, but we'll represent them with dots just to show that they are electrons of potassium. So this is how we are going to complete the electronic diagrams for K2S. For the C part, they are telling us that ionic compounds form giant ionic lattices. Yes, they form giant ionic lattices, which means they form three-dimensional regularly arranged pattern of cations and anions in them. They're saying this figure 2.2 shows part of a giant ionic lattice structure of sodium chloride. So this is a part of NaCl crystal, which contains Na positive and Cl minus ions. They want us to complete the diagram at this figure to show the ions present. They want us to represent the positive and negatively charged ions in it. Use plus for sodium ions and minus for chloride ions. One chloride ion has been completed for you. So as we see here, they have shown this. One chloride ion is shown here. We are supposed to complete rest of the pattern. So dear children, as we know that opposite charges attract each other. So with minus, we should draw plus adjacent to it. And also we should make sure that for one Na plus, we have one Cl minus only. So the pattern goes like negative, positive, negative, positive. And then because here we have negative, so opposite to it, adjacent to it will be positive, then negative, then positive, then negative. So we should take care that it's like plus, minus, positive, negative, positive, negative. So it doesn't let any of the similar charges come closer. Its adjacent charges are opposite to each other. So that's how we'll get 2 marks for this. Now they're asking state the name given to the positive ions. That's so simple. Do we not know that cations are positively charged ions? If we don't remember this, we can remember it with this mnemonic which says cations are positively charged. This is how we can remember it. Cations are positive. Moving on to D part, ionic compounds can be decomposed by the passage of electric current. Do we know this? That when we pass electricity through molten or aqueous solution of ionic compounds, they break down. They're asking the name of this process. What do we call this process as? So this process is called as electrolysis. Electrolysis is the breaking down of an ionic substance in the presence of electricity. The word electro is related to electricity and lysis means breaking down. What they want us to do in the next part is write the ionic half equation for the reaction which takes place at the anode. Anode is the positively charged electrode. When molten potassium bromide is decomposed by the passage of electric current. So they are saying that we had a setup. We know the setup for electrolysis is like this, that we have two electrodes, anode and cathode. We connect it to battery. This is anode, this is cathode. Anode is positive, cathode is negative. And here we have the electrolytic solution filled, which can be molten ionic compound or can be aqueous solution of ionic compound. In this case, what they are saying is that we have molten potassium bromide. So this is KBr liquid. Now, dear children, when this is KBr liquid, so it will definitely have K plus and Br minus in the system, right? A lot many K plus and Br minuses will be there in this here. At the anode, let's focus on the anode. Now, tell me which ion will go to anode. Anode is positively charged. So definitely Br minus is going to go there. So we'll start our reaction, the half equation with Br minus. And you tell me that if this is Br minus molten, then at anode oxidation happens, right? Oxidation happens at anode. Please remember this. Now, what is oxidation in terms of electrons? Is oxidation loss of electrons or gain of electrons? Yes, oxidation is loss of electrons. We remember oil rig, which says oxidation is loss of electrons and reduction is gain of electrons. So now we know what to do. We know that, okay, oxidation is going to happen at anode. So Br minus will lose its electron plus electron. And what will it become? It will become Br, right? But the point is that Br do not exist as Br. Br exists in diatomic form, two atoms together. So it's going to be Br2. And for that, we need to balance the further reaction. We'll have two bromide ions, and one bromide ion loses one electron, and two bromide ion will be losing two electrons. So it's going to be like this. Now, this is how we obtain a brown colored gas at anode in this case. So we see bubbles of brown colored gas rising up. The third part of the question is name the products and state the observation at the negative and positive electrodes both. When dilute aqueous potassium bromide is decomposed, now it's not liquid, they're saying it's aqueous. Now, dear children, they want us to talk about the aqueous KBR's electrolysis, and that too, what are the observations and what is going to happen at both the electrodes. So we should make note that this time H plus and OH minus ions will also be there in the mixture because it's aqueous, KBr in water. So K plus and Br minus, H plus and OH minus. So they want us to talk about the negative electrode first. So let's talk about that. So at negative electrode, which of the ions will go? Definitely the positive ions will go at the negative electrode. So K plus and H pluses, they will go towards the negative electrode. Now, dear children, we know that negative electrode is called cathode. And what happens at cathode is reduction. Reduction is gain of electrons. So, okay. K plus and H plus will go to the anode. They will be attracted. They'll be attracted to the cathode because of the opposite charge of cathode to them. But we have to decide that, okay, which of these K plus or H plus will get reduced. Now, dear children, for this we need to know reactivity series. The element which is less in reactivity will get reduced. Now, out of K plus and H plus, which is less in reactivity, it's H plus. So we'll start with H plus and H plus because it's reduction, so it will gain electron and get converted to H. But because we know H exists as H2, not just H, so this is going to be balanced. We are supposed to balance it. We'll do it like this. 2H plus ions will accept 2 electrons and will give H2 gaseous. So the product at negative electrode, okay, we need not to write the whole equation here. They just want us to tell the product at negative electrode. So we will say hydrogen gas, or we can say bubbles of hydrogen gas will be produced. When they say observations at the negative electrode, so we'll say bubbles. Bubbles of H2 will be seen. This is the observation, that we'll be seeing some bubbles. Product at the positive electrode. Now, dear children, they have given us two blanks because two products will be obtained at the positive electrode. Now, at the positive electrode, we know Br minus and OH minus ions will be there, right? So what's going to happen is, now we have to decide that which of these will get oxidized, because what happens at anode is oxidation, right? So we have to decide that which is going to be oxidized here. Now, if it would have been concentrated solution, then definitely Br minus would have got reduced. Please remember that. Please note that whenever concentrated solution of halides is there, then halogen is reduced, halide ion is reduced. But because here what is happening is that there is dilute solution. So because of that, what will happen? OH minus will be the one that will get reduced. Let me tell you the reaction that happens there. So at anode, what happens is OH minus gets oxidized. So OH minus aqueous. Oxidation means loss of electrons. So it is going to lose electron that will get converted to O2 and H2O, and it will lose electrons. And this reaction is balanced this way. This is what happens. So when they ask us what are the products at the positive electrode, so it's O2 and H2. Oxygen and water will be produced. Observations at positive electrode are bubbles of oxygen gas are seen. I hope you have understood this. Thank you very much.